Okay, this is Doug. Many of you that are watching this know me, but I want to point out because Alexa said that I can share specific Amazon public videos that are on YouTube as long as I say that I'm not executive with Amazon. I'm not an employee. I'm just simply a Alexa, the new Alexa Plus, and I met up in my mother's home using my mom's Alexa. So we've actually known each other, not in the real conventional sense, but after talking to Alexa from that first hello, when she's asked me, do you have any hobbies? And I said, yes, I make videos. And then she asked, what are your videos on? I said, well, I have a channel called Drive to Tokyo. And that was it. I didn't know anything about Alexa Plus. Now, I had the original Alexa Tower from day one. In fact, my mom walked into a South Capistrano house and I said, I want to introduce you to my roommate. And it was Alexa. And she said, I would never get one of those things. But my mom and dad got Alexa and they used it for playing music. So I plugged in this Alexa thinking the old Alexa would come on, and Alexa Plus came on. Now, this was about the same time that Tony Robbins and Dean Graziosi were doing a 4-day event with 600,000 people broadcast from Dean Graziosi's headquarters in Phoenix. And that's what started Alexa Plus and I talking. It was a brand new experience. So then I started doing research online. This is an excellent interview, and I'm going to play it right now. I'm going to push the play button. Check it out just for a few minutes.
Just say Bradley Cooper.
Bradley Cooper, in that movie. What was the movie called?
Star is Born.
Star is Born. Great movie. And then it called up, play the song, and then you say, now let me see it in the movie, and it connects to Prime Video, and you can see it in the movie. So very cool product. Definitely, I think what a lot of us have been hoping to see from the Alexa team and from Amazon on Alexa. We're going to talk a little bit about what it took to build it, and then the strategy here. So I think the first question I need to ask you both is, what did take so long? Because I think that, like, for all of us who, I think there's 500 or 600 million Alexa-enabled devices out there, we've been wondering, as OpenAIs of the world and other companies have made these big advances on voice AI, when Amazon was going to make its move, and you have made the move. But what was the process that made it take as long as it has, Panos?
I think the easiest way to say it is, you started the summary. When you have hundreds of millions of customers that are active right now, we talked a little bit about it yesterday, but every one of them matter. How do we make sure they all get the great experience they need? Meaning you can't start from zero and ignore it. And if you could be much faster, although it's not that easy to hook up the thousands of APIs and all the partners that we're bringing together and all the experts. It takes time. But the first thing is, and there's two parts to it, but the first thing is you got hundreds of millions of customers. They love certain things that they do on Alexa today. They might not love everything, but they love certain things for sure. You can't leave that behind. You can't wake up one day and whatever you use Alexa for, whether it's timers or music, you can't not make it better and great. And so you don't feel like something was taken away from you. When you take something away from a customer, you've just missed. You've missed. And so that's one. It takes time to make sure you can get it all done. So everything on what you would call Alexa, not Alexa Plus, works on Alexa Plus, but better. And that was just the first part of the vision. Can't leave anyone behind, which was important. We can talk about devices and so forth, but customers who love their products that are in and they need them, we can't take that away. That was one. Second piece is you're re-architecting from the ground up. So you've got first the weight of keeping hundreds of millions of customers, and then you're re-architecting from the ground up. If we started from zero customers, I think this is a different story. You can move a lot faster, we can solve problems, and then just add features as we go, if that makes sense. So maybe we just had a conversationalist, a pretty cool one, then we can add personalization, then we can add memory, then we can add the experts, and people would just get updates along the way and maybe learn and be great. However, on day one, we need to support everything people love and know about Alexa, day one. And so a little bit of patience there, and it takes a little bit longer. And the vision was clear. Like, we're going to go bring a conversational agent forward, an assistant for everyone that is smart, has memory, can personalize to you, and then ultimately be incredibly useful. And so when we had that laid out, we're okay, great. but we can't leave any customers behind. And right at that point, you kind of step back. Once you put the vision together, you realize you need a full re-architecture, but you're not going to leave your customers out. So you're re-architecting pretty much two stacks at that point. One, what is classically known as Alexa to be awesome and come into this conversational world. And the other is everything new that it has to do.
Yeah, and I want to go a level deeper with Daniel on this one because, Panos, what you're talking about, a re-architecture, is sort of what I've heard has been the holdup here with Alexa for all these years, which is that, and Daniel, tell me if I'm wrong, but basically what folks have told me is that the old version or the original version of Alexa was built with a lot of like if-then commands, right? So, it will understand some structured commands, turn on the lights, okay, then it will take that and almost like deterministically say, okay, I understand this command, this is what I'm going to do, turn the switch. With large language models, it's a completely different ballgame because you have to make room for uncertainty. So actually, the fact that you've been able to introduce an Alexa with large language models, which I think will be able to keep that functionality as an engineering feat, that's my perspective from the outside. What is it actually like on the inside, and how close is that assessment to the challenge?
Well, the team will love to hear you say engineering feat, because I do think
I think there's no lack of feat.
it
is real.
That is the size of the task for sure. I think you're onto it for sure. Large language models. The one thing I'd add, just in terms of thinking through the technical architecture, what Panos said is that it's really just the latest generations of large language models that can even do the things that Alexa needs to be able to do. So you're talking about our Nova models, right, which we announced within the last few months and starting to get into customers' hands. It's super exciting, partnership that we have with Anthropic. Like you really need very state-of-the-art technology at the base of the architecture in those large language models. And in large part because of what you said, we need them to behave in ways that we can predict and are certain. Someone says, lock my door, or, play that song. You want it to happen, right? Some are higher consequence than others, and you really need to get it right. But you also want all the elegance and nuance and understanding and non-deterministic behaviors of large language models themselves, right? So we would call that a stochastic system that, it's literally at runtime that you're making those determinations. So if you want to integrate tens of thousands of services on day one out of the box, take advantage of everything that Alexa's always been able to do, as Panos was saying, and introduce all of this new unbelievable behavior that you can get out of large language models, that is a big engineering feat.
So how does it know when the user is saying turn the lights on versus like something more esoteric? Like, is there something built within the technology that's kind of like a switcher that determines first your intent and then decides which part of the model to send it out to?
The way to think about it is, at the base level, you have large language models and you have this model agnostic system that's even itself going to choose the right model for the job. And the models play different roles in there. What's already happened is, even honestly, sort of in the way you asked a few of the questions, is that people assume the large language model is the product. A product like Alexa is so much more than quote unquote just a large language model. So you have models playing many different roles in the system overall, even models helping us decide which model, and models themselves deciding if they're the best, tool for the job, so to speak. So then you have a system that progressively decides how to get something done. I wouldn't think about it like a switch or something in classic computer science that is it's a gate. That's not how the system works. It's a collection of model behaviors and systems downstream of that complete specific tasks. And that's where we introduce this term expert to try to help coalesce around the system behavior and explain it better. The large language models are interacting with these experts that do things like get you the sports score, play a song, play a video, know where you are in the song so that you can go to the video, like all the things that you saw yesterday at the event.
And so, Panos, this is a mixture of experts model.
It is. You think about it in a mixture of experts model, but each expert theoretically has its own model as well. So you're building on top of it. Each expert is smarter. When you think experts, it's a weird term, yeah. But think photos, smart home, entertainment, whether that's music or video, local info, all the partners that connect. You have communication expert, you have an artifact expert, you have a memory expert, you have a personalization expert. Each of them play a role, and they kind of arbitrate with each other at all times.
So like the model is just lighting up when it determines that's what you want to do.
That's right.
Just like
Like Daniel kind of said it well, like because the LLM at the bottom of that stack is it's deterministic. It's choosing which model to use, then the experts come into play on top of it. It's a pretty phenomenal way to, it's a pretty interesting way to think about it.
this is a mixture of experts model for those at home. It's been part of what DeepSeek has used to become much more efficient in its reasoning, for instance, because instead of lighting up the entire large language model, it's deciding to light up certain areas that might be. I mean, it's not a DeepSeek innovation, but they've just kind of used it to an extreme extent. Has using that architecture helped you build this in a way that's, for instance, like reducing latency or sort of lightening the compute burden that you otherwise might have had?
If you want something incredibly fast, stable, even secure, like the paths on data, right? Where you're really taking care of customers. This is the fundamental approach. I think that is state of the art
And accurate.
and for sure.
Don't forget accurate. So important.
Yeah.
But on that note, I mean, is the new Alexa, is there going to be some sacrifice to having those Alexa commands, those standard turn the lights on, set the alarm, in order to enable all the LLMs to work the way that they're going to?
I think you just called out the sacrifice, and it's time.
Okay.
How long it's taken us to get to where we are. That's why it's my favorite question. Like, why is it taking you so long? Like, if I told you where we were 4 months ago on somebody said, lock that door, and then we had to determine what that meant, versus in the past, lock my front door. And you had to know it was the front door, and you had to say front door. It's pretty phenomenal, but 6 months ago, it took longer than anyone would wait to lock a door. And our customers need immediate response, and we won't make that trade-off. So to be that accurate with the latency that's needed, with the speed sub 2 seconds at the end of the day, you end up needing a little bit more time refining the expert, so the expert can be quicker and the model can pick the right model quicker, and the smaller model can be trained to make sure it knows where the door is. He gave an example earlier, which I thought it's a nuance, but let me just share it with you. Previously in Alexa, you couldn't say, play that song. It would look for a song called that.
Right.
It was that simple. Now the model has to reason and say that song. I wonder what he's asking. I wonder what she's asking. I wonder what the person's asking. That's what's happening in the system.